Hello. Now we will calculate the heat required in case of isobaric process as well as the internal energy change in case of isobaric process. So as we already know, the change in internal energy formula for any process, not just for isobaric, is equals to NCV dt, where CV is the heat capacity for isochoric process. The value of CV is F by 2, where F is degree of freedom. This one is degree of freedom. So we have this ready-made formula. We can use this formula anywhere we want, in any process we want. So this is the formula we are having in terms of temperature. And one more thing we have calculated in the last lecture, that was the work done by gas. In terms of temperature, when we calculated the work done by gas, that came out to be equals to nR dt. In terms of pressure and volume, it was P delta V, but in terms of temperature, it was nR dt. So we have calculated the work done by gas as well as the internal energy in case of isobaric process. Now, if you go by the first law of thermodynamics, so from first law, which says dq is equals to du plus dwg. If you see this formula, if you put the value of work done and the internal energy change into this formula, you will get dq is equals to ncv dt plus nr dt. That will give you dq is equals to n cv plus r dt. So this becomes the formula between the heat given to the system and the temperature change. Okay, if we rewrite this formula for 1 mole gas, it becomes dq is cv plus r dt. One more time, if we rewrite this formula, the new format will become dq upon dt is cv plus r. And if you see this side, dq by dt, this value is nothing but heat capacity, molar heat capacity. The formula for molar heat capacity is dq by dt. And in this time, this dq by dt we have calculated for isobaric process. So this will become the molar heat capacity for isobaric process, since dq by dt we have calculated here for process where P is constant. So we had a formula for molar heat capacity. The molar heat capacity C was equals to dq by dt, or we can say it was delta q by delta t. So if we replace the value, dq by dt at constant P, we will define it as Cp, and that will be equals to Cv plus R. If we write the value of Cv in terms of degree of freedom, so if we replace the value of Cv from the degree of freedom, that formula, the Cp will be equals to F by 2 times of R plus R. The Cv is, R is there. So the Cp will become F by 2 plus 1 times of R. The value of Cp, where F is degree of freedom. Okay, so we have calculated the internal energy, which is same for every process involved. We have calculated the work done by the gas for isobaric process, and from there we applied the first thermodynamical law, and using that we have calculated the Q as a function of temperature. From there we have defined the molar heat capacity for isobaric process, and that value came out to be F by 2 plus 1 times of R. Now the thing is, if we know the Cp, we can directly calculate the dq, because you see this formula. In this formula, we can also write this formula as Cp dt. So whenever there is an isobaric process, we can directly calculate the heat given to the system by just calculating the temperature. Now we have all three values, internal energy change and work done and heat given to the system in terms of temperature. So if we know how much temperature is changing in the process, we can directly calculate these three values by using these formulas. Okay, and the temperature is a state function. You see, it does not depend upon the process. Once it is changed, it is changed. So you just calculate the temperature, critical temperature at the critical junctions, and by calculating the temperature at those critical junctions, we can calculate these values. Okay, thank you.